what you did? Destiny, go ahead.
All right. Well, you start off writing
Right.
H or H naught. After that, you start off by writing the DF. The DF is the row minus 1 and column minus 1. So you have 2 rows, 4 columns, and that's how I got 1 and 3. Multiply and get 3. Once you find that, you'll look at your chart and find that the CD is 7.815. Just to show that you know what you're doing, you have to calculate the first point, which is going to be 24, and the last one, which is 51, so E11 and E24. You get the row total and the column total divided by the actual total of all the data. That's how you get 3664. After you put in your calculator matrix, you should get x squared is 14. Chi-squared, sorry, is 14.15. After that, you can obviously conclude that you're going to reject H naught. So you have enough evidence to reject the claim that there's no difference in the proportion of people in each economic group.
How do you know that's a matrix? What are you focusing? How do we know that this is a matrix? What do you mean by the chart? There are columns and there are rows?
Yeah. And there's all data.
Right, so I have, and it's all what inside?
There's like all data in it, like there's no missing points.
Ah, right, and these are not, so a couple of ways. One is you can pay attention that you can recognize that these are people who said yes. Does that kind of make sense? These are not, this is not like, you know, how long is it? Or what is your grade? This is how many people said that there are these columns. So these are frequencies. Does that make sense? Not numbers. Not measurements, I should say. Okay. Next one. I let go of what we did for this one.
It's pretty similar. So I started with the hypotheses, the H naught that we expected, observed and expected are equivalent, and H1 that they are not equivalent. And so then in the second step, the first alpha we're using is 0.05, and the degrees of freedom is found by the number of rows minus 1 times the number of columns minus 1, which is 4. And then you use the chart to find that your critical value is 9.488. And you draw a little picture. And then for the third step, you have to show that you know how to calculate the expected value. So you do the very first one, and you multiply the row total and the column total divided by the total number of values. I forgot, for this one, they didn't have all the totals, so you have to add them, and I wrote them all in. And the final, you do the last one as well, so the expected value for row 2, column 5. That's how you get the 54.22 for the initial one, and the 45.30 for the last one, the matrix. And then you put the matrix into your calculator and you do the chi-squared test. Get that your chi-squared value is 45.31, which is so far off to the side, you know you're going to reject H naught, which concludes that there's enough evidence to support the claim that there is a relationship between vertebral class and its endangered or threatened status. And then it also
hold on. So the claim was that there is a relationship. So relationship is H1. So Isla said, okay, H1 is my relationship, is my claim, so I'm going to use the word support here. So this is like kind of the proper way of doing it. You could do the simple way. I'm totally fine with you. The simple way of saying that you can reject the claim that the proportions are the same. That would also be fine. Everybody okay with that part? Either reject that the proportions are the same, or you do the correct one versus along this side. Okay, great. Go ahead.
And then it also asks if there's a different result for the 0.01 level of significance. And so I calculated that on the side where I wrote the alpha, and then you can find the critical value again by your degrees of freedom won't change, and then you use the chart but 0.01 this time, and you get that the critical value is 13.276. is still not enough to not reject H naught, and so the result does not change, and the original conclusion holds at that level of significance.
Right. So, so what it's saying is that when alpha is 0.01, your critical value changes because your critical value depends upon alpha. So that's saying, okay, what if we made it a little bit harder to prove it's correct? You need to be 13.277 or more. That has no effect at all on your test stat. Your test stat is all about your sample. You calculate totally based upon the sample. Alpha and your critical value, that's what you're comparing it to. That's your picture and your shading. So your picture and your shading depend entirely upon alpha and your degrees of freedom. Right? So kind of the what's unusual or not unusual. The test stat, the 45.31, that's not affected at all by alpha. It has nothing to do with alpha at all. That's all about your sample. Good? The matrix you stuck in. All right. Good. So now, finally, we will move on to 11.3, ANOVA. So remember, chapter 10 was all about means. Right? We had, or not means, but like numbers. Our data was numbers. So we did have X bars and Y bars and stuff like that in there. But basically our data was numbers. For chi-squareds, 11.1 and 11.2, our data were proportions. Our data were yeses and nos, categories. You ask a person, what was the last one? What, are you happy or not? And what income level do you fall in? Kind of, are you in the first group, middle group, second group, or last group? Or vertebrae. Are you, what kind of vertebrae are you? Are you an amphibian or are you a reptile? And are you endangered or are you not endangered? Right? So what you're finding out about people is what categories they're in. And what we did was we figured out how many were in each category. Right? So these are all categories. And so what do you know about each species? You know what type of vertebrae it is and whether or not it's endangered. You know categories about it. Now we're going to talk about means, where the data you know about things are numbers. So now we're going to compare means. The nice thing about means is, how do I know something's a mean? It'll say mean or average. Right? So here, we're testing that means are equal. So our H naught's going to be that mean 1 equals mean 2 equals mean 3 equals mean 4, however many means we have. H1 will be at least one difference. It's really hard to do ANOVA, so we're just going to let the calculator do it for us, and we're just going to focus on interpreting the results. So this ANOVA test has really almost no math in it. You only have one tiny bit of math, which is comparing your p-value to alpha. What's our guideline for unusual? 5% or less. So if you are 5% or less, or if you are alpha or less, then you're unusual. If you're unusual, we're going to reject H naught. If you're not unusual, then H naught could be fine. All right, so we're going to get our p-value and find out if it's unusual. If it's less than or equal to alpha, we're going to reject H naught. If your p-value is more than alpha, then H naught's probably fine. You can't, it's not unusual. You did not get an unusual result. Is everybody with me? Remember back when we were finding finding cards, and people who got a red card would get a chocolate, and we got an unusual result. We got 6 or 7 black cards in a row. So that's when we rejected it. We said we got something unusual. We're gonna reject the null hypothesis and say that Ms. Young, your deck is not a regular deck. It's fixed somehow. It's different, right? So H naught says that you're regular. If you get something unusual, then that's not true. You're going to reject H naught. So here, that's what we're looking at. We're going to compare our p-value to alpha. Right, so what's being compared? I do want us to take a little look at what's being compared in ANOVA. We're comparing the variance between the groups to the variance within the groups. The idea being that if the groups are all have the same mean, then their variance between the groups should be about the same as the variance within each group. Let me give you an example. We talked about this last class, right? We had first graders, fourth graders, seventh graders. So the first graders are all down here. They're all short. The fourth graders are all over here, and the seniors are all up here. So within each group, there's not that much variance, 5, 6, 7, maybe 7 inches. But between the groups, between the kindergartners, first graders, and the seniors, there's a big difference. Right, it varies quite a lot. So the between group variance is much bigger than the within group variance, right? So when you look at that ratio, you're going to find it's going to be a number larger than 1. The F-stat is this number right here. It's the variance between the samples divided by the variance within the samples. So if your F-stat is large, that means that the variance between the samples is much bigger than just the variance within the samples, which means that they're not the same. The means are not the same. I do expect you to understand this idea that the variance between the groups, if that's a lot bigger than the variance within the group, that's how you figure out what your F statistic is. It's the ratio of the between group variance to the within the group variance. So I will give you a bunch of stuff, including the between group variance or the between sample variance, and I'll give you the within sample or within group variance, and I'll ask you to compute the F statistic. You can never compute it with data with your calculator unless I give you all the data, like all the lists. Does everyone understand that? So you're not going to be able to compute the F statistic using your calculator. Instead, you're just going to take the between group variance and divide by the within group variance. Now, I'm not going to make it easy. I'm going to give you a bunch of other stuff too, right? Like alpha, some mean, some other things just to confuse you so that you have to find these pieces. All right. Good? Understand what's going on? Okay. Just so you know. All right. So number 1. These are the steps. State your hypotheses. Michaela, thanks for volunteering. Go ahead and read for me.
Step 1, the hypothesis. H naught mu1 equals mu2 equals
Up to mu k. Right.
up to mu k. H1, at least one mean is different from the other. Step 2, find the alpha. Step 3, compute the p-value. Put the first group into L1, next into L2, last into L3, and then stat, test, ANOVA, L1, L2, L3. Fourth step, make a decision to reject H naught or not. And then step 5, summarize.
Great. So these are our steps. All right, so here's your quiz problem number 2. I don't think anybody did it. Is that correct? I didn't have anybody write it out. Okay, so first of all, how do I know that this is an ANOVA?
Because it doesn't have rows, it just has
Like-
columns.
Yeah, because I don't have labels. There are no labels on the side. Does everyone see that? A contingency table, a matrix, will have labels along the side and labels across the top. This one doesn't have this. So Sky, this is just 3 lists instead. Make sense?
Yeah.
Okay. What's another way that we know that it is an ANOVA? It says mean on it. Exactly. See where it says mean? So that's another really big clue. This is not chi-squared, and it's a mean. So in theory, it could be chapter 10 or this one. However, chapter 10 only has 2 lines of data, and they're matched up in pairs, they're points. This is not 2, this is 3 lists. Everyone see this? And they're not matched up in pairs. So anytime you have 3 or more lists, That's ANOVA. Because 2 lists, we would just do a 2 sample t-test. Right, so there's 3 or more lists, you're good to go. This is ANOVA. Great. All right, so then what's my first step?
Your claims.
Yep. mu1 equals mu2 equals mu3. Perfect. Drew, what's my H1?
That mu1, that mu1 doesn't equal mu2.
Ah, so you can't say that. You can't say which one is not equal. All you can say is at least one differs.
Oh.
Because maybe mu1 is equal to mu2, but not equal to mu3. You don't know which one. You don't know which one. You don't know which one differs. So at least one differs. You have to do it like that, right? Because you're not sure which one. Some of them might be equal, but some of them aren't equal. And you don't know which ones are equal and which ones aren't. All right, so, and then my claim is going to be, so 11 goes with 0, so that means that H naught is going to be my claim. Step 2, Angelo, what's my step 2? Oh, actually, you don't have to worry about that. It's just super. What's that? Yeah, so this one, all we got to do is write down what our alpha is. What's our alpha? 0.05. Yeah, alpha equals 0.05. Done. That's it for step 2. Very straightforward. Okay, so then we got step 3. So I'm going to do this. I'm going to put this into, I'm going to tell Ms. Young, I've already told Ms. Young, I'm going to put this into list 1, I'll put this into list 2, and put this into list 3, so she knows that I put the right things in the right list. And then I'm going to do ANOVA. Stat test ANOVA, my bad. Stat test ANOVA, so she knows I use my calculator to do this. L1, comma, L2, comma, L3. And then I'm going to get my p-value of, help me out,
0.054.
0 what?
0.054.
54. Great. Perfect. Okay, good. Done. Step 4. Now I need to compare them. How do I compare them? Diego. I'm calling Diego all today. Diego, how do I compare them?
You write your p-value, 0.05 or 0.054.
0.054.
Then you link space, and then you write your degrees of, your alpha, 0.05.
And then what I'm going to do is I'm going to make them have the same number of decimal places. So 0.05, I can add any number of zeros after that I want. So I'm going to add 1, so they match up. Okay, keep going.
And then you just,
Yeah, what's it bigger, 54 or 50 people?
54.
Good. So then it's my p-value is larger. So then, Diego, what'd you say from there?
so,
Do not reject. Right, because it's not 5% or less.
Yeah.
Do not reject H naught. Good. And then, step 5, Juliana? What do you have for step 5? Yeah. Not enough evidence to reject the claim that the means are the same. Good? Yeah, Scott.
So where's the variance, like the f equals variance divided by?
I'm not gonna ask you, that doesn't come into play in this at all. So that never comes into play here at all, which is why I need to do a separate question just to have you find the F statistic separately.
The final is the variance difference,
So the F is the between group variance divided by the within group variance. I never have you calculate that here because it's too complicated. So instead, I'll have a little separate tiny question with just a few points where I ask you to find the F statistic.
Okay.
And I give you some of the pieces. But yeah, it doesn't come up in here at all. Right, so I have to ask you that, I have to ask that separately.
Okay.
Yeah, thank you for asking. Okay, so how do folks feel about ANOVA?
Pretty good.
Pretty good? Okay, so what we're gonna do is we're gonna do two more. Lab problem 10 and, or is only one more? Oh, and lab, yeah, yep, lab problem 10 and lab problem, the one on the next page. So do those two problems, this one and that one?
Yeah.
Yeah, they're big one, that's 1 and 2.
Okay, got it. All right, so do these two problems, that one, and then we'll check the first one in like 6 minutes, and then we'll do the next one. But do both of them.